Okay, in U3A2, we're going to look at a galvanic cell, or also called a Daniell cell. And I want to go to the reaction first, so I'm going to go down here and try and spell out what's important. So we're going to use what we learned before. Remember, SO4 is 2 negative. I'll try and use SO4 in my examples, and that way we remember it's 2 negative. So if something's a solid, it stays as it is. It gets a charge to 0. If it's aqueous, we break it up. So we have one Cu, we have one SO4. We said the SO4 is 2 negative. You just have to remember that. So the Cu has to be the same because this is a 1-to-1 ratio, 2 plus. We have Cu0. We'll break apart the Zn. It's 2 plus the SO4, which is 2 negative. Now what we do is we cross out what we have on both sides, which is the SO4, and now we look for our redox reaction. So we can see that Cu2 plus is reduced down to Cu0. So that's our reduction. And Zn0 goes up to Zn2 plus. And that's oxidized. Okay, so this is our redox reaction that's occurring in this cell that's up here. This is a battery. We have zinc, which is a solid. It's got a negative charge, so that's the anode. So look for the negative, that's your anode. Then we've got copper, which is positive, and that's the cathode. So when we're doing this, we have an anode and we have a cathode. And what happens is the ZnSO4 and the CuSO4 break apart, just like I've talked about down here. So whatever is being oxidized is written on the left. Whatever is being reduced is written on the right. They show a porous barrier in the content. I show what's called a salt bridge. So we have to have ions or charged particles going back and forth to balance the charges. But this is what it looks like. So all the electrons flow towards your cathode, or whatever is being reduced. Lots of great videos out here on galvanic cells or Daniell cells. Make sure you watch a couple. So what you have to be able to do is draw a diagram with the anode on the left, the cathode on the right. You have to be able to do net ionic equations to show what's being reduced and what's being oxidized. Whatever is being oxidized, you write on the left, Zn, single line to Zn2 plus. The double line separates these two parts of the battery, Cu2 plus to Cu. So this is separating what's being oxidized and what's being reduced. So this is being reduced, it's going down to 0, and this is being oxidized. The skills you need to be able to do is you have to be able to do the half reactions to see what's oxidized and reduced. You need to be able to do your drawing, and you need to be able to do this half reaction. Now, the last thing that they might want you to do is they might want you to find the charge on this. So what they've done is they've given you a chart in there of all the half reactions. And if you subtract what's being reduced and what's being oxidized, it will give you the charge in the system.